Last week, Google open sourced Longfellow ZK, a zero-knowledge proof cryptography toolkit that lets you prove something, like that you're over 18, without ever showing the actual secrets. Think of zero-knowledge proofs like this. Alice wants to prove she has the right key without handing over the key itself, so she puts the key in a lockbox, presses a button, and out comes a little slip that says, yes, that key fits. Bob sees the slip and is convinced, but he never sees the key itself. Longfellow ZK gives you math blocks, the hidden gears that do all the secret calculations, ready-made circuits, pre-built designs for things like password checks or age tests, as well as proof maker and checkers. Two simple C++ calls, one to build your proof, one to verify it. In order to build and test Longfellow ZK, you can simply use GitHub code spaces with the publicly available repository. So first you're going to want to click code, then it'll bring you to code spaces, and you want to create a code space on main. VS Code spins up a dev container with everything you need, including compilers, testers, benchmarks, all pre-installed. Inside your dev container terminal, we're going to come down here to building manually, and then we just have to first copy this step, obviously press allow, then we'll copy this step once that's done, and then this will just take a quick moment to build all of these. So we've actually had 97% of the tests have passed, but 6 of them have failed. We're just going to ignore that for now and move on to the next step. So we're going to want to run the benchmarks. So the first one we can try out is this one. It'll only take a moment, and then we can run the next one. All right, now that those tests have run, we're going to do the next one. So the first one is core math steps, like shuffling numbers. And the second one is making a simple proof check for something like verifying you hashed a password. Now, as we can see here, these are so fast that the user probably won't even know that the implementation's happening, or at least they won't be hindered by it, which is quite powerful. Some examples of useful possible implementations include driver's license validation for rentals, student or staff discounts, digital asset ownership, financial threshold proofs, and compliance and access controls. Some more innovative implementations that could be possible include, number 1, AI model accountability. So you can use a zero-knowledge proof to show your model's training dataset met compliance criteria without revealing the data itself, protecting intellectual property and trade secrets. Number 2, genetic privacy in healthcare. So you can avoid discrimination or data leaks by proving medical facts without sharing your full genome. Number 3, decentralized social media proofs. So you can use zero-knowledge proof for your ownership of a Twitter, Instagram, Threads account without linking it publicly. Number 4, skill-based matchmaking in gaming. So you can prevent smurfing or rank spoofing without revealing full account history. Number 5, sustainable consumer claims. So a brand can prove a product was made using recycled materials or fair trade labor without disclosing proprietary supplier information. Number 6 is borderless remote hiring. So as global remote work grows, HR departments want compliance without invasive data sharing. And number 7, legal age for region locked content, which we've sort of mentioned before, where you basically just have region specific age and location verification without exposing full ID details. Number 8 is supply chain auditing. So you can verify provenance without leaking competitor sensitive sourcing paths. Number 9 will be micro-credential stacking. So you don't have to disclose your full resume, just that you meet the hiring bar. So number 10 is DEFI risk scoring. This is our final one. And basically you can bring compliant and private identity or risk metadata into pseudonymous finance, otherwise known as sort of like the unique identifiers for finance. Overall, with Longfellow ZK, you can prove things without storing anyone's personally identifiable information or other secrets, keeping user data private and your service compliant.